Children, today we will start new chapter organic compounds containing nitrogen, and our first topic is amines. So amines are alkyl or aryl derivatives of ammonia. As you all know that molecular formula of ammonia is NH3. So when one or more than one hydrogen of ammonia are get displaced with alkyl or aryl group, okay, in this condition the compounds which are formed are known as amines. In this way, okay students, so the alkyl or aryl derivatives of ammonia are known as amines. In other words, we can say that the amino derivative of alkane or benzene are known as amines. Okay students, so in short we can define amines in two different ways: alkyl or aryl derivative of ammonia, or we can say that amino derivative of alkane or benzene are known as amines. Okay students, the next heading is classification of amines. So before this, this last line, amines are the alkyl derivatives of ammonia. Okay, so as you can see, with the help of this change or conversion, ammonia from ammonia, when one hydrogen atom is get displaced with alkyl group, then amine is formed. Again, from this amine, one hydrogen is displaced with alkyl group, so this amine is formed. And at last, one more hydrogen is get displaced, this amine is formed. Okay, so this amine, the first one is known as primary amine, second one is secondary amine, and the third one is tertiary amine. Okay students, for example, methylamine, and this methylamine is a type of primary amine. Okay, ethylamine, this is ethylamine, and so on. Then classification of amines. So according to the first classification, amines are classified as primary, secondary, tertiary according to as 1, 2 or 3 hydrogen atoms of ammonia molecule are replaced by aryl or alkyl groups. Okay students, so the first type of amines are known as primary amines. So as you can see here, that primary amines are represented as RNH2, where R is alkyl group, or also we can represent as ARNH2, as you can see here. So AR is aryl group, okay, this is aryl group, and H2. So such amines are known as primary amines. Okay, in other words, amines which are having an H2 as functional group, are known as primary amines. So primary amines are formed when one hydrogen atom of ammonia is get displaced by alkyl or aryl group. Okay, so as you can see here, in these all amines which can be aliphatic or aromatic are having an H2 as functional group. Okay, so these all are the example of primary amines. The next is secondary amines. So the secondary amines are the alkyl or aryl derivatives of ammonia which are formed due to the displacement of 2 hydrogen atoms of ammonia. So secondary amines are having functional group as NH group. So amines which are having NH group as functional group are known as secondary amines. Okay students, so these secondary amines are formed when two hydrogen two hydrogen atoms of ammonia get displaced with two alkyl groups or two aryl groups. Okay, students. So these alkyl or aryl group can be same or different. So that will be depend on the type of amine, but overall secondary amine will carry this NH group as functional group and formed due to the displacement of two hydrogen atoms of ammonia. Okay, students. Now, secondary amines can be of two types, simple and mixed amines. Okay, so simple amines are the secondary amines in which both the alkyl or aryl groups are same, as you can see here in this amine. This secondary amino group and this amino group is attached with two carbon chains of same number of carbon atoms. So these are the simple amines, but this is the simple amine, but this one which is attached with two different carbon chain is an example of mixed amine. Okay, students. Then tertiary amines. Tertiary amines are having functional group as N, means all three hydrogen atoms of ammonia get displaced by alkyl groups or aryl groups or both alkyl or aryl groups. Okay, so tertiary amines are having functional group as N only. Only N is there, and all three valencies are connected with alkyl or aryl group. Okay, students. So these are the examples of tertiary amines. Now again, tertiary amines can be of two types, simple tertiary amines and mixed tertiary amines. So simple tertiary amines which are having all three same alkyl or aryl groups attached with tertiary amino group, as you can see here. So in this amine all three methyl groups are present, so it is a type of simple amine. But in this, two carbon chains are same, one is different, so it is an example of mixed amine. Okay, so simple amine, mixed amine. The next heading is quaternary ammonium compounds. So in quaternary ammonium compounds, which are also known as quaternary ammonium salts, the compounds having general formula R4N plus X minus are called quaternary ammonium compounds. So as we all know, ammonium salts of ammonium salts. So this is ammonium ion, this is halide ion. Same way in quaternary ammonium salts, in organic chemistry, all four alkyl or aryl groups are attached with nitrogen, central nitrogen atom, which are together forming positive ion, and then one negative ion is present there. It might be some halogen or some other negative ion like nitrate or sulfate. So in such way, quaternary ammonium salts are formed. Quaternary, in which central nitrogen atom is attached with four same or different alkyl or aryl groups. Okay, students. Then next classification is depending upon the nature of groups attached to the nitrogen atom. Amines may also be classified as aliphatic or aromatic amines. So if the carbon chains which are attached with amino group are open chain, then such amines will be known as aliphatic amines, and if benzene rings are present in the compound with amino group, then such amines will be known as aromatic amines. Okay, students. The next type is aryl-alkyl amines or aryl-alkyl amines. Aryl-alkyl amines or aryl-alkyl amines. So in such amines, both benzene and alkyl chain will be present, but the amino group is attached with carbon chain. So such amines are known as R-alkyl amines or R-alkyl amines or aryl alkyl amines. Okay, as you can see in these amines, the amino group is attached with carbon chain, which is further attached with benzene ring. Okay, so in R-alkyl, amino group will not directly attach with benzene ring. The next heading is nomenclature of amines. So according to IUPAC nomenclature, if some simple amine is there, primary amines, so these amines are considered as amino derivative of alkane. So suffix is used as amine, root word plus ane plus amine. Okay, students. So root word meth, because this is saturated chain or one carbon chain, meth, ane, amine. So methane amine means methane. So E will be displaced by amine group because this is vowel here. So methane amine. So the name will be methanamine. Okay, students. And same way we will name other primary amines also. As you can see here, the primary amino group is present at second carbon. So propane to amine. Propane to amine. Okay, students. Propane to amine. This will be the IUPAC name of this compound. Okay, students. So we are going to consider just IUPAC names only. Okay, so as you can see here with the help of this table, these are the primary amines. So 3 carbon with amino group, so propanamine, because this amine group is present with first carbon 1, 2, 3. So propanamine, IUPAC name. In this second carbon is carrying amino group, so propane to amine. These are the example of secondary amines. Same chains are present. So out of these 2 chains, one will considered as alkyl group attached with N, and second alkyl group as amine. Okay, so N-methyl methanamine. N-methyl methanamine. Okay, so in secondary amines, if both the carbon chains containing same number of carbon, so one carbon chain will be considered as alkyl group attached with N, and second alkyl chain will be made as amine. Okay, students. So methyl, which is attached with N, so N-methyl methanamine. In this is shorter chain, this is longer chain. So short chain will be considered as alkyl group and long chain as amine. So methyl, which is attached with N, and methyl ethanamine. And methyl ethanamine. Okay, students. Again 2 chains same. So any one of can be considered as alkyl or any of as amine. So ethyl ethanamine. So ethyl is attached with N and ethyl ethanamine. Okay, students. Now for tertiary amines. For tertiary amines, if all the 3 chains are same, so any one you can make as amine, any one chain, and rest 2 will be as alkyl group. So N-dimethyl methanamine. N-dimethyl methanamine. And here one is long chain and 2 are same chain. So these 2 shorter chain will be considered as alkyl group. N-dimethyl ethanamine. Here all 3 chains are different. So longest will be taken as amine and rest 2 as alkyl group, but in alphabetical order. So N-ethyl, N-methyl propanamine. Okay, students. Then for aromatic compounds, so this benzene, amino derivative of benzene is considered as aniline, IUPAC name and also general name. So aniline. One hydrogen is replaced with a methyl group. So it is the methyl derivative of aniline, methyl derivative of aniline. So N-methyl aniline, N-methyl aniline. Okay, students, and so on. One more example is here given, this one. So this we are considering as the phenyl derivative of this carbon chain. So 2-phenyl propane 1-amine. This is the first carbon, propane 1-amine, or you can simply write propanamine, 2-phenyl propanamine. Okay, students. The next heading is isomerism in amines. First is chain isomerism. So as we all know that in chain isomerism there is difference in carbon chain. Okay, for example, if you are going to make chain isomers of this C4H11N, so this is the first structure with C4H11N butanamine. Okay, so for forming a next chain isomer we have to keep this portion as such in the second compound also, and we will try to do variation in the rest chain of the compound. So for the variation, this carbon will be shifted here. So second isomer, this is simple chain isomer, and this is isomer. Okay, iso. So first is N-butylamine and second is isobutylamine. Chain isomer, difference in carbon chain. Second type is position isomerism. In position isomerism, position of functional group will be vary in different isomers. So for example, in the same compound C3H9N, we can form two compounds. In first amino group at first carbon, so it is propanamine, and here it is propane 2-amine. Same way for C4H11N, we can draw two isomers, butane 1-amine and butane 2-amine. Okay, students. In aromatic compounds, we can form position isomers. First, you can see here 2-methylbenzenamine, or orthotoluidine. So this is the ortho position on the basis of this methyl group. So this whole is toluene. Okay, students. So you can say 2-amino-toluene. In this way also you can say. Okay, but this is the major group. So 2-methylbenzenamine, or you can say 2-methylaniline. This one is 2 in this methyl group is present at third position from here. So 1, 2, 3, 3-methylaniline, and this is 4-methylaniline. Okay, students. So these are the position isomers of aromatic amines. And the next type of isomerism is metamerism. Okay, so for the example of metamers, we considered two compounds, ether, and first is ether and the second is secondary amines. Okay, students. So in secondary amines we can show metamerism also. So for example, C4H11N, this is the first structure where this bivalent functional group is having two chains attached with it, and these chains are ethyl and ethyl. In the second metamer, this is bivalent functional group and it is attached with carbon chain, 3 and 1. Okay, so these two are having different carbon chains attached with NH group. This is the third metamer. So here the chains are changed. This is methyl and this is 2-propyl chain. Second, with the second carbamino group is attached. Okay, so all these three are having same bivalent functional group with but attached with different carbon chains. So these all three are metamers of each other. Okay, students.